Hey nine, so here is a video on solving equations. So today we're going to look at one-step, multi-step, and equations with variables on both sides. Now, I know a lot of you might have been taught a whole variety of different methods by your teacher, but I am going to show you a method today, and I would like you to actually use this method when you are solving your equations. So we've talked about this whole idea of the language of math and the fact that we need to all know how to express our answers in a similar way, and that when we're using the correct language, everybody can understand it. So the language I'm teaching you today is the language I want you to use when you're solving equations. All right, so the one-step equations, the reason they're called one step is because only one thing is happening to x. So if we look here, x is being multiplied by 3. Here, x, we're adding 10. Here, we're dividing x by 5. Here, we're subtracting 2/3 from x. And here, we're squaring x. So there's only one operation being that's happening to x. Okay? So when you are solving these equations, now many of you can probably do them in your head. You can look at this and guess and check and say, wait a minute, if x is 9, then 9 times 3 is 27, and so that's 27. And that's not what we're going to do today. Today, we're actually going to take a look at how to do these algebraically so that no matter how complicated our expressions get, we're always going to get the right answers. So, to begin, um, when you have a lovely one-step equation like this to solve for it, what you want to do is you want to get x all by itself. All right, so right now x is being multiplied by 3. We want to get x all by itself. Well, we know that if we do the opposite operation, we can do that. So if I divide this by 3, then I'll end up with 1x. So whenever you have a multiplication question, you can do the opposite operation, which is division, to get x by itself. So let's try that. So we're going to take this, and I'm going to divide by 3, and I'm going to divide by 3. So when I divide this side by 3, 3 divided by 3 is just 1, so I have 1x. So I have x, and 27 divided by 3 is 9. And that's exactly the answer that we got when we guessed and checked. So moving on. So in our next question here, we're adding 10. Well, I know if I have 10 and I take 10 away from it, then I'm left with nothing. And so then I would just have x on this side. So the opposite operation, or the opposite thing we want to do then when we have addition questions, is to subtract. So I'm going to write out x plus 10. And then to get rid of that 10, well, I'm just going to subtract 10. And because I've done it to this side, I also want to do it to this side, because as you can see in the middle here, there's this lovely equal sign. And the only way to maintain equality is if you do something to one side, as long as you do it to the other, it doesn't matter what this turns into, these two sides will remain equal. So here, 10 minus 10 is just nothing, so I don't have to write that, so I have x. And negative 3 subtract 10 is just negative 13. So now, um, I now know that x is negative 13. Well, I can try it. Negative 13 plus 10 is negative 3. Yep, that worked. So on to the next one. So here I have x divided by 5, which is equal to negative 5. So my opposite thing that I would normally do here is I'm dividing. So if I multiply x by 5, then I can just cancel them. So opposite to division is multiplication. So I want to take that x and I want to multiply it by 5. So I'm going to do 5 times x, and then that's all over 5. And then because I've done it to this side, I need to do it to this side. So I'm going to do negative 5 times 5. All right. So again, these cancel. So now 5 divided by 5 is just 1. So I have 1x. And negative 5 times 5 is negative 25. So my answer is negative 25. And I can check it. No, negative 25 divided by 5 is negative 5. So yep, that worked. So moving on to another one with, but this time again we have subtraction. So in order to get rid of the subtraction, I want to do an addition. So I'm going to add 2/3 to both sides. So I'm going to take x minus 2/3 plus 2/3 equals 1/5 plus 2/3. So again, if I have a negative 2/3 and a positive 2/3 here, I know that's going to be 0. So that means I'm left with x, and x is going to equal 1/5 plus 2/3. So now I just have to remember how to add and subtract fractions. So when I add fractions, I need to make sure I get a common denominator. So I can get the common denominator by multiplying 5 by 3. Well, I know that 5 times 3 equals 15, so my common denominator is going to be 15. So I'm going to take this 5 and I'm going to multiply it by 3, and I'm going to take this 3 and I'm going to multiply it by 5. So if you remember from grade 7 and 8, when you get a common denominator, whatever you do to the denominator, you also have to do to the numerator in order to maintain that consistency. So we're going to take that 1 now, and we're going to multiply it by 3, because we multiplied 5 by 3, and we're going to take this 2, and we're going to multiply it by the same thing we multiplied the denominator by, which is 5. So now I have 3 over 15 plus 10 over 15. And when I add and subtract expressions, I just add the numerator. So 10 plus 3 is 13, and the denominator stays the same. It's kind of like when you're adding and subtracting terms, right? If you add 2x and 3x, you get 5x because the x stays the same. So it's the same thing here. Your denominator stays the same. You're only adding the numerators. So now I know that x is equal to 13 over 15. So this last one, x is being squared. Well, the opposite operation to squaring, so if I take a look here, if my exponent is a positive integer, so 2 is a positive integer, then the opposite to that is taking the root. So if it's a square, it's a square root. If it's a cube root. So that means what I want to do then is I want to take the square root of x squared and the square root of 121. So when I take the square root of x squared, I just get x because that's undone the operation of squaring by square rooting it. And then I want to find the square root of 121. So if I bring my calculator over here, right, if I take a look at it, I have this lovely square root operation here. And so I can do the square root and then 121, and it returns and tells me that it's 11. So that means that 11 times 11 is 121. So my answer then is going to be 11. Now, later we'll talk about the fact that there's really two answers here, and you might know that already, but for today, I'm okay with just the positive answer. So x is equal to 11. All right, so moving on. Multi-step equations. So the only difference between single step and multi-step is now there are two operations that are happening to x. So we're multiplying x by 2, and then we're adding 4. And on this side, we're multiplying x by negative 3, and then we're adding 4. And here, we're multiplying x by 2/3, and then we're subtracting 4. So the idea of applying opposite operations to both sides of the equation still holds for these. But the order that we do it in is what's important. So normally, when you solve a question, you solve it using BEDMAS. So, when you simplify it, an equation, you would simplify it using BEDMAS. So you would do your brackets first, and then your exponents, and then your division, your multiplication, your division, your multiplication, your addition, and your subtraction. Well, here we're not actually doing any math on this equation because we can't simplify this any further. So in order to undo it, then we have to do everything in the opposite order. So in the opposite order, we're doing SAMDIV. So first we would subtract and then add and then multiply and then divide and then exponents and then brackets. So if we look at this equation, we have 2x plus 4. So the first thing we want to do, there is no subtraction, so we want to get rid of the addition. So we're going to get rid of the addition by doing the opposite operation to addition, which is subtracting 4. So I'm going to do 2x plus 4 minus 4 is equal to, and again, 6 minus 4. So I've subtracted 4 from this side, and I've subtracted 4 from this side. So when I subtract 4, well, 4 minus 4 is nothing, so I'm just left with 2x. And on this side, 6 minus 4 is 2. And so now I know that 2x equals 2. And so now I have a one-step equation. My x is being multiplied by 2. So I want to do the opposite operation, which is division. So I'm going to divide both sides by 2. And x is now equal to 1. And I can go back and double check it. 2 times 1 is 2, plus 4 is 6. Yep, I got the right answer. So let's try that again. So now I have negative 3x plus 4 equals negative 5. So again, I start, there's no subtraction, right? Because this is negative 3 times x. There's an addition. So I want to get rid of that addition. So to get rid of the addition, I do the opposite to addition, and opposite is subtraction. So I'm going to subtract that 4 from both sides. So when I simplify this, well, positive 4 and a negative 4 make nothing, so I'm just left with negative 3x. And negative 5 subtract 4 is negative 9. And now I just have the one operation, so x is being multiplied by negative 3. So I'm going to do the opposite operation, which is divide. So I'm going to divide by negative 3. And so negative 3 divided by negative 3 is just 1. So I'm left with 1x is equal to, and negative 9 divided by negative 3 is 3. So 1x is equal to 3. And again, I can check it. Well, negative 3 times 3 is negative 9, and negative 9 plus 4 is negative 5. So check that's the right answer. Last one. So here I have 2/3 x minus 4 equals negative 12. Well, what I want to do is I want to take that 2/3 x, and I'm going to take this and I'm going to rewrite it. So if you remember, 2/3 x is the same thing as 2x over 3. So I have 2x over 3 minus 4 equals negative 12. So now I've got a lot going on. I'm multiplying x by 2, I'm dividing x by 3, and I'm subtracting 4. Well, when I look at SAMDEB, the first thing I want to take care of is the subtraction. So I'm going to do the opposite operation, which means that I am going to add 4 to both sides. So now I want to simplify again. So negative 4 and 4 makes nothing, so I'm left with 2x over 3 equals negative 8. Because negative 12 plus 4 is negative 8. So now what I want to do is I want to keep going. And so now as I follow up, I have multiplication and division. So here I'm multiplying x by 2, so now I can divide that by 2. So I've got 2 x, and I want to divide 2x by 2, so I'm putting that 2 in the denominator. That 3 is still there. And then that equals negative 8 divided by 2. And so now I have those 2's divided by 2. I've got 1x, so now I have 1x over 3 equals negative 8 divided by 2 is negative 4. So I'm going to keep this rest of this question up here. So I have x over 3 equals negative 4. Well, now my x is being divided by 3, so my opposite operation would be to multiply by 3. So I multiply x by 3. Then I'm going to multiply negative 4 by 3. So again, 3 divided by 3, I just have 1x. So I have 1x equals negative 12. And I'm done. Again, I can check it. So I have x is negative 12, so 2 times negative 12 is negative 24, divided by 3 is negative 8, and negative 8 minus 4 is negative 12. Yep, I got the right answer. So moving on to the last one. So I want to solve equations with variables on both sides. So this changes things a little bit when you have variables on both sides. So look, we have x's on this side and we have an x on this side. And we've got numbers on this side and we've got numbers on this side. So what I want to do then is when I have equations with variables on both sides is the very first step is to simplify both sides. So see if there's any way you can simplify this. So we just did a whole thing on simplifying algebraic expressions. We have like terms 3x and 2x, so we're going to add those together, and I'm going to get 5x minus 4. Then I'm going to look, can I simplify the other side? Nope, there's no like terms, so that's just going to stay as x minus 24. So now I have a variable, a constant, a variable, and a constant. Constant just means the number. So if I look at my next step, I want to take have all my x terms on one side and all my constant terms on the other side. So that means that on this side, let's say I want all my x terms. So I want to get rid of this minus 4. Well, just like over here, when I got rid of this 10, I subtracted 10. Oh, you can't see that. Sorry. Just like above, where I wanted to get rid of this 10, I subtracted 10 on both sides. I'm going to do that exact same thing down here on my equations with variables on both sides. So this minus 4 is going to disappear, so I have to get rid of it. I have to add 4, so I'm going to do 4x minus 4 plus 4 equals x minus 24 plus 4. So I'm going to add 4 to both sides. So now when I subtract 4 and I add 4, I have nothing. So I'm left with 5x equals x, and negative 24 plus 4 is just negative 20. So I still have a problem because I have an x over here, so I want to get rid of the x on this side. So to get rid of the x on this side, I'm obviously going to subtract an x. So I have an x. To get rid of it, I'm going to subtract it. So I'm going to subtract that x from both sides. So I'm going to subtract the x over here, and I'm going to subtract the x over here. So now 5x minus x is 4x, and x minus x is nothing, so I'm left with this negative 20. And so my last step now it looks just like what I had at the beginning. I have a one-step equation. So here I have 4x. It's being multiplied. To get rid of it, I do the opposite operation, which is divide. And so I have x equals negative 5. So what I want to show you really quickly now is, how do I know that's the right answer? So because I can't just put it in anymore because I have x's over here. So I have to actually check both sides of my equation to see if that's the right answer. So first we're going to take the left side of the equation, which is 3x minus 4 plus 2x. And what I want to do is I want to put this x equals negative 5 in so I can see what answer I get when I do all this math. So I'm going to go 3, I'm going to replace x with negative 5. I'm going to subtract 4. I'm going to add 2. And I'm going to replace the x with negative 5. So I have negative 15 minus 4, and then 2 times negative 5 is negative 10. So I have negative 15 minus 4 minus 10, and so when I add all of that up, I end up with negative 29. So that's the answer when I put x into the left side of the equation. So since this and this are supposed to be equal, if I can get the same exact answer when I replace x into here, so let's check the right side of the equation. So my right side, so I'm going to replace is x minus 24. I'm going to replace the x with negative 5, and then I subtract 24. And so now I have negative 5, subtract 24, which is negative 29. Well, when I evaluate the left side, I get negative 29, and when I evaluate the right side, I get negative 29. So I know my answer must be negative 5 because it gives me the same answer when it's evaluated. So therefore, left side equals right side, and therefore the answer is correct. Okay, so I know I got the right answer, and so I am now finished. Hope that helps. Bye.